Well, hello class.
Hello. Hello.
Well, we're going to look into finding the relative extrema, actually might even wind up being absolute extrema, of this function f of xy is 1 minus the quantity x squared plus y squared to the 1/3 power. And so the first thing we would do is investigate the partial derivatives of this thing. Of course, derivative with respect to x of 1 is 0. Derivative with respect to x of this expression is 1/3 times this expression, so that's where this 3 came from, times this expression to the negative 2/3, so I put it in the denominator to the 2/3 power, and then times the derivative of the inside function, which is 2x. The negative comes from this negative sign right here, so that's the partial with respect to x. Similarly, the partial with respect to y is almost the same except for the y in the numerator instead of the x from the derivative of the inside function. So it's apparent that both partials are undefined at the point 0, 0, and I don't know if you see why that's the case, because if we have 0 for x and 0 for y, we've got a 0 denominator in both cases. Also, neither partial can be 0 unless it is at the point 0, 0, because look at the numerator. So the only critical point is the point 0, 0. Actually, kind of for two reasons, because the partials are undefined, and maybe also because the partials are 0. So notice that f of 0, 0, if you go back to the original function, f of 0, 0, if you put 0 for these, f of 0, 0 is 1. And f has smaller values for any other xy, because this would be a positive number that raised to the 1/3 power cubic of a positive is subtracted from 1. So point is, a number is subtracted from 1. So therefore 1 is the largest possible value of f of xy. So therefore it's a relative maximum, and you can actually see from the graph that it's an absolute maximum. And here is a picture of this thing. Kind of has a peak at the point where x is 0 and y is 0, and has a peak value of 1. You can see that from the side.